Welcome to MD Bytes. In this video tutorial, I'm going to show you the implementation of linked list using Python. Initially, I'm going to start with a demonstration for all linked list operations, and then I'm going to show you the Python code to implement those operations. So here is the glimpse of the output I'm going to generate in this tutorial by creating the functions for both insert and remove operations in linked list. So these are the functions I'm going to create for insert operations for inserting a node into a list. And then these are the remove functions I'm going to create to remove the nodes from the list. Now let's get into the video. Basically, linked list is a linear data structure type where every node in the list consists two parts, which is data and next. Data part contains the data and the next part contains the pointer to the next node in the list. In a linked list, the first node is called as root node, followed by the other nodes in the linked list, where the last node will not have a pointer in the next part. So then it shall be identified as the last node of the list. Now let's get into an example. So this is our list and I'm going to insert a new node at end. So this is our new node, which is 400. To insert a new node at the end, we need to just extend the next pointer to the newly added node. And to add a new node at the beginning of the list means to insert a root node, we need to restructure the list. We need to move the nodes to the next positions. You can see the demonstration. Each and every node in the list will be moving to the next positions, and then the first position means the root node will be empty. So now I'm going to insert this 400 as a root node, and the next pointer in here will be pointing to the first node. So this is how we insert a root node. Now let's get into the next example for removing a node from a list. So here node 100 has been removed by restructuring the pointer of the previous node to the next node by skipping the in-between node. So this is how we remove a node from a list. Let's move to the Python implementation. So I'm creating a class named node in here, and I'm going to have a constructor in this class. So this constructor will have a data variable. So I'm going to have a variable named as data, and this will be assigned to the variable. So here I'm going to create two variables. The first one is data, which is a part of node, and I'm going to assign this with the data which I'm going to pass in later, and then I'm going to create another variable for next pointer. So the variable name is next, and this will be assigned with none. So these are the two parts of a node. So I have created those two as the variables, so which will be assigned with values later for implementing the operations. So now I need to have another class for implementing the linked list operations. So I just create another class with the name of list. So this class is going to have the functions for implementing the operations. So here again I start with a constructor. So I just type def and I enter init. So this constructor function is here to have the variable for root node. So I just declare self dot root node. I'm going to name it as root underscore node. So this will be the root node variable, and I'm assigning this with none. So right now it is assigned with none. Later it will have values in the rest. So now I need to create another function for implementing the operations. So first I'm going to start with insert a root node into the list. So I just type def and I'm going to name this function as insert underscore root node. So this function is created to insert the root node, where it should have a variable. So I just declare a variable as data. So this data is going to be the one which will be added as a node into the list. And to receive the variable newly added data, I go with an object variable called current node. So I have created this object variable for the class node, and I'm going to pass in the data as the parameter. So this is how I'm going to assign the data into here. So now I need to first check whether the root node is empty or not. For that I just go with an if condition. I just type if self dot root node, and I'm going to check whether this is empty. So I just type is none. If this is true, then I go with a simple assignment. I just type self.root node, and I'm going to assign this with the current node where we have the value of the newly added data. So that data will be assigned as root node. Else, if the root node is not empty, then I go with current node dot next, meaning that this object brings down the next variable declared in the class node, which should have the next pointer. So this will be assigned with self dot root node. In case of root node is not empty, the current node's next pointer will be pointing the root node, and now self.root node will be again assigned with the current node data. So I just type current underscore node, where it consists the data which is created newly, which is inserted newly. So now let me create a new function for displaying the items in the list. So I just type def, and I'm going to create a new function named as print underscore list, and this function is going to be a no parameter function, as I'm not going to pass in any variable. So I just go with current underscore node, the object, and I'm going to assign this with self dot root node. The first node of the list will be assigned, where I'm going to create a loop. So first I check while current underscore node has any data. So for that I just type current underscore node is not none. So until or unless we have data in current node, this loop has to performed. So I just type print, and I'm going to print the data. So for that I just type current underscore node dot data. So this brings the data, this brings the item, and print. And then after printing, it has to move on to the next positions. So for that I just type current underscore node, and the current node must be assigned with the next value. So that I just go with current underscore node dot next. So then the next item in the list will be now the current node. So then the iteration will be repeated to print all the items until the current node becomes empty. Now let me move to the executable statements and check whether the functions work properly. So I create an object my underscore list, and I'm going to assign this with the class name list. So this is the class which I have created to perform the linked list operations, and now I'm going to call the function. So I just type my underscore list dot, so the function which I have created to insert the root node. So I just call that particular function. So I just type insert underscore root node. So this is the function. So here I'm going to key in the data. So I just type 100. So 100 is the value, 100 is the data I'm going to insert as root node. So once this has been done, I'm going to print it. So I just again call my list dot, so this time I call the print list function which I have created to print the items from the list. So I have called both the functions. So that's it. So I have inserted a root node, and I have called the print function to print the items in the list. Here is the execution. You can see the output displays the value 100, which has been inserted as a root node, and the print function also performs well as it displays the item from the list. So now I close the execution and get back to the code to create a new function. So I'm going to create a new function for inserting a node at the end of the list. It means that I'm going to perform an operation inserting at the end. So I'm going to name this function as insert underscore at end, and this function will come up with a parameter which is data, through which I'm going to receive the value to be added at the end of the list. And then I'm going to create a variable, an object variable, temp underscore data, through which I'm going to receive the data. So I assign with node within brackets data, so that the new item will be stored in here, and then I'm going to check whether the list is empty or not. So by using if condition, if self.root node is none, I'm going to check whether the root node is empty or not. If it is empty, it is simple. I go with self.root node root underscore node will be assigned with temp underscore data. That's it. The newly added item will be the root node now. Else, if the root node is not empty, or if we have nodes in the list, we need to find out the last node. So I go with current underscore node, the object variable created earlier. So I'm going to assign this with the self dot root node. So root node will be assigned to this current node, so then we can access both data and next variables. So I have assigned self dot root node, and I'm going to create a loop to find out the last node. So I go with while, and I'm going to run this loop until the current node becomes false. So it means that I'm going to access the next pointer. So until this next pointer becomes false, the loop has to work. So I just go with is not none. So until this next pointer is empty, the loop will be performed. So I go with current underscore node, and I'm going to assign this with the next pointer. So current underscore node dot next. So then the loop will be performed until the next pointer of the current node becomes false. Once it becomes false, means that that will be the last node. So I'm going to assign current underscore node dot next will be assigned with temp underscore data, the newly added data. So the new data will be added in the next pointer of the last node. That's it. We have constructed the code to insert a node at the end of the list, either if we have nodes at the list or if the list is empty. So now let us do check with the executable statements. So now I'm going to call this function. So I just enter in here, and I'm going to call the object my underscore list, and I'm going to call this function. The function name is insert at end. So through which I'm going to pass in a data. So I'm going to pass 200 will be the data. So this is going to be added at the end of the list. So I'm going to execute it. So then all these three statements will be executed. So let's check it out. Here is the output. You can find both the values have been printed in the output, both 100 and 200. 100 as the root node and 200 as the last node of the list. So that's it. We have added the node at the end of the list. I have closed it. Now I go back to the code, and I'm going to create a new function for inserting a data in between the list. So I'm going to type for creating a new function. So I'm going to name this function as insert underscore at between. So I'm going to insert node in between the list. So this function will have two parameters. One will be position, and then normally as other functions data. And in this function I'm going to have a new variable called count, and I'm going to assign this with value 1. So this count variable will be used for calculating the positions in the loop. And then I'm going to create a new variable current underscore node, and then this will be assigned with the root node. I just type self dot root node, where this current node will carry the root node for the loop. So here is the loop. I'm going to first check whether the count variable is less than position minus 1, means that the value of position will be detected with value 1, and that will be checked whether it is less than count. And then I'm going to check whether the current node is not none, means that I'm going to check whether there is value in the list. So now if these both conditions are true, then I'm going to move to the next nodes. I'm going to give current underscore node equals current underscore node dot next, means that the next pointer will be pointing to the next node in the list. So then this process will make a count. So I just give count plus equals 1. So then this while loop will be ending by finding out the position as the current node, and I'm going to create a new object variable for the class node, and I'm going to receive the value of the data. So the data will be received in here and stored in temp underscore data, and then I'm going to access the next pointer of the node class. So I'm going to have the code temp underscore data dot next. So I'm going to assign value for the next pointer of the newly added data. So I just give equals, and I'm going to give current underscore node dot next. So the current node next pointer will be now the newly added node's next pointer. So then it's simple now. I just go with current underscore node dot next will be the temp underscore data, the newly added data. So this newly added node will be inserted in between the list as the current node has been identified by the loop. Now let's move down and check it out in the execution. So then I'm going to call this function by using the object created earlier. So I go with my underscore list. So this is the object. So I go with insert at between, so the newly added function. So this time I'm going to pass in two values, so one for position and another one for data. So I'm going to give the position as 2, so 2 will be the position, and data I'm going to key in as 500, so 500 will be the data. So I'm going to execute it. So then just after the root node, after 100, this 500 has to be added into the list. So this is the execution in here. Yes, let me drag a little bit up. Yes, you can see the output 100, 500 and 200. 100 as a root node, and then 200 has been inserted at the end, and 500 has been inserted in between. Even then the function has been called at last. The 500 has been inserted in between 100 and 200. So that's it. This is how we construct the code to insert a node in between the list. So now let me close the execution and move on to the next function. So next we are going to work on removal operations. So for that I'm going to create a new function to remove the root node. So now let me continue from here to create a function for removing the root node. So I just type def, and this time I'm going to name this function as remove underscore root node. So this function is to remove the root node. We are not going to pass any parameter, just starting with the if condition to check whether the root node is empty or have any value. So I just go with self.root node, and I'm going to check the condition is none. So if this condition is true, it means that if the root node is empty, then it just returns none. So this will be the output. Else, if we have any value in the root node, I go with a new variable called temp. So I just type temp, and I'm going to assign this with root node. So I just type self dot root underscore node. So then root node value will be assigned to this variable, and then to restructure the list, I just type self dot root node. This will be assigned with the next node, so that I just type self dot root underscore node dot next. So the next immediate node will be now the root node. So now I'm going to delete the variable temp. So then the existing self.root node value will be deleted. So this is how we delete a root node from the list. So now let's move to the execution part and check the implementation of remove root node function. So I just drag down, and I'm going to key in the executable statements in here. So before that, I'm going to insert a print statement to have a clear reference of remove operation. So for that, I just type print within double quotes. I'm going to key in as remove space operation, so it will be very clear for us to look into the output. So now I'm going to call the function. So I just call the object first, my list dot remove underscore root node. So this is the function which will be called for removing the root node. So I'm going to execute this. So then the root node, the 100, will be removed, and then the next node, which is in the second position, 500, will be the first node after this. So here is the output. So you can see the list of items in the list, and the output stops with the remove operation text. So this is because I haven't included the print function to display the items of the list. So now what I need to do is I need to include the print function again after the remove operation. So then I can find the list of items after the remove operation. So I just copy this line, and I'm going to paste it in here, and again I'm going to execute it. So this is the output. And now you can see the root node 100 has been removed after the remove operation. So that's it. I'm going to close the execution, and I'm going back to the code, and this time I'm going to create a new function to remove a node from the end of the list. So for that I'm going to declare a function. So def, this time I'm going to name this function as remove underscore from end. So this function will also not have any parameters, as it just removes a node from the list. So this time again I'm going to check whether the root node is empty or not. So I go with if self.root node is none. If this condition is true, it means that if the root node is empty, then the output must be none. So I'm going to type return none. So this returns the output as none. Else, if we have value in root node, then I'm going to declare a variable as current node, and I'm going to assign the root node to this variable, whereas I'm going to use this variable in the while loop for finding out the last node in the list. So before starting up of the loop, I'm going to create a new variable for identifying the previous node. I have just keyed as prev and assigned with none. So this will be the last before node. So now let's start the loop. So while current underscore node dot next, so means that I'm going to check the next pointer of each node, and I'm going to check is that not empty. So is not none is my code, and if this is true, I go with previous node equals current node, and then I'm going to assign the current node. So I'm going to type current node will be assigned with current node dot next value. So then the previous node will be now the current node. So this process will be repeated until the while loop gets ended, means that while loop will be getting ended at the last node. So once the while loop gets end, we go with previous dot next will be assigned with current node dot next, so that the current node's next pointer will be now the previous node's next pointer. So then I'm going to delete the current node. So that's it. We find the last node. The last node will be the current node, and then that particular node will be deleted. So this is how we construct the code to remove a node from the end of the list. So now let's go down and look into the execution statements, and I'm going to include this particular function for removing a node from the end, and I'm going to check out the output. So before implementing it, since the items are very less in number, I wanted to add one more item in the insertion process. So I just go in here and I'm going to insert one more item at the end. So I'm going to key in my list, and I'm going to call insert at end function, and I'm going to insert the data. So this time I just key in as 600. So 600 will be a new node will be added at end. So this node which has been added at the end is to be removed by applying the function remove from end. So I just key in my underscore list, the object name, and I'm going to call the function remove from end. So this is the function which we have constructed to remove the last node from the list. So once I do execute, the last node 600 will be removed from the list. Now let me do execute and check it out the items in the list in the output. So here it is. You can see the list of items before remove operation and after remove operation. So these are the nodes we have inserted by using insertion functions, and then after remove operation the 600 have been removed by the help of remove from end function. So this is how we remove a node from the end. So now I do close the execution, and let me get back to the code in the above. So then I'm going to create a new function for removing a specific node from a particular position of the list. Means I'm going to create a function for removing a node in between the list. So I'm going to name this function as remove underscore in between. Since this function is going to remove a node in between the list, so I have named it as in between, and this function will have a parameter which will be the position. So based on the position value, the particular node will be removed. So initially I'm going to check whether the node has any value. So I'm going to check if self dot root underscore node, which means that I'm going to check whether the root node is empty or it has any value. So I go with the code is none. If this is true, means that if the root node is none, if the root node is empty, then the output will be none. So I'm going to return none in the output. else if the root node is not empty, then I'm going to create a new variable which is current underscore node, and then I'm going to assign this variable with the value of the root node. So I just type self dot root node, so then the root node value will be assigned to here, and I'm going to create another variable which is prev, so this is going to be used as the previous node, so I just set it as none. Then I'm going to have another variable for counting the positions, so I just declare this variable with value 1, and then I start with the iteration process. So here I'm going to check whether the root node is empty or not. So then I'm going to check the current node is not none, means that the current node has any value. If this is true, and then I'm going to check another condition where the count must be less than the position value, means that we have some nodes in the list. So if both these conditions are true, we shall set up the iteration statements. So I go with the previous variable, and I'm going to assign this variable with the value of current node, meaning that the root node will be assigned to this variable which is empty earlier, and then I'm going to assign the variable current node with the value of the next node. So the next node will be in current node dot next. So I just assign the value of the next immediate node to the current node. So this will be repeated, so each and every time when this repeats, the variable count will be added with a value. When the count less than position becomes false, meaning that the position is identified, so the loop comes out, and then this code previous dot next will be assigned with current node dot next, meaning that the previous node will be assigned with the current node next value. So then the current value, the current node has to be removed. So I just delete current underscore node. So that's it. I have removed a specific node from a particular position mentioned in the position value from the list. So now I move down to the executable statements to execute this function. So now let me include the function in here. So I'm going to call the function by using the object my underscore list dot remove in between. The function name is remove in between, and I'm going to pass the position value. So the position value I'm going to pass is 2. So the value, the node which is in the second position will be removed. So we have set of nodes in the list 100, 200, 600, 500, and also we have implemented few remove functions already. So let's check it out in the output. So here it is. So we have 100, 500, 200, 600. Since I have already removed the root node, so the 100 has been removed, and then 500 has been moved to the first position as the root node. So now the node 200 will be in the second position. So 200 has been removed from the list, and 600 is also removed since I have implemented remove from end. So only the node 500 remains in the list. So that's it. We have implemented all the linked list operations using Python in here. So this is the code for implementing the operations, and this code is also available in the description link. You can download from there. And thanks for watching.